No worries. Thanks. Well, it's great to be here and great to be part of this growing community. I'm Mike, and so I'm a tech lead at Blocker. We're a London-based music technology company. So I'm really excited to hear Skylar's talk later on audio programming as well. So I'll definitely stick around for that one. But at Blocker, we build a lot of cloud applications in Go and running on Kubernetes. So what I wanted to talk about today was the concept of a 12-factor app. Which is a concept some of you may have heard of. It's a principle for building cloud applications that are flexible, meaning that they're easy to change the application, the code, the configuration, and ultimately the behavior of the app. They're scalable, so that path from 100 to 100,000 users is easier to follow, and resilient, and that sort of translates to better uptime and correct application behavior for your customers. And these are 12 tried and tested principles that originated at Heroku, the cloud platform. And they're people who make their living by enabling others to run apps in the cloud. And these have proved to be very popular principles. There's a lot of myths, so I'm going to avoid the why for each of these principles. That's much been written about that. And I'll encourage you to Google around on the topic. But instead, I want to focus today on the how, and give you more of a practical guide to actually implementing these principles for Go applications specifically, running in Kubernetes. So without further ado, I'll run through each of these principles. The first one is code base. So it means one code base tracked in revision control with many deploys. I hope most of you are already using Git or some other version control system, but a key idea of a 12-factor app is that it consists of multiple processes, which is an idea that we'll return to later. But here I'd like to share some project structure best practices to handle this. And they've emerged from many projects across the Go community. And you can learn about them with this link here at the top. But a key idea is we have many app entry points, all of inside of this command folder at the top here. You can then build each of these entry points into multiple binaries, multiple applications just within a single repo. And these entry points can all leverage code organized into packages in the shared package folders. And on the top level folder, that should be semantically versioned. It's code that anyone can import and depend on, whereas the stuff inside of internal can't be imported externally to the project, and that's enforced by the Go compiler itself. So it's a nice pattern to take advantage of. The second principle is dependencies. Be explicit about your dependencies, declaring and isolating them. So in Go, this means use Go modules. Since Go 1.11, Go modules has been available. If a dependency isn't available as a module, then vendor your dependencies, check them into version control. You can be explicit about them that way. Don't assume an underlying architecture other than what you define in your Docker file. That means the OS or the chipset, and any system-wide packages should be installed using run directives in the Docker file. So it's being very explicit about what you're doing. The third principle is about changing the behavior of your app. Change the behavior using environment variables. Everything should be driven by environment variables. So a single container image build should be able to run in each of your environments, whether that's local, staging, CI, production, just by changing the environment to match the environment variables to match that environment. And a good way of doing this in Go is to use Viper and Cobra, which is a complete configuration solution for Go applications. It's used in a whole host of popular open source projects, and it's automatically loaded from the environment. I'm getting knocked on. Yeah, I've got the key. Yeah, I've got the key, thanks. Serious. I'm still in the office, everyone's going home. So yes, another thing you can do is in a cluster itself is to use config maps. So you can define all of your environment variables in a config map or create your secrets for those passwords, and then you can bind those to your deployments in Kubernetes. So it's a really easy way of doing it. The fourth principle is about backing services. So treat all of the services that your application interacts with as attached resources. And that means every service should just be accessible via a URL. So here we've got a service environment variable defining where we can access an app that we're going to make a gRPC call to. and we can use kuberesolver so that we can specify this Kubernetes protocol. The kuberesolver will use the Kubernetes API behind the scenes to resolve the service endpoint IP address of this service. Another thing to remember when your service is interacting with others is don't forget health checks. So for example, you have liveness and readiness probes that you can configure on your Kubernetes deployments, and they use Kubernetes to check that your application is running and it's available and that it's ready to accept incoming requests. And you can easily register your checks for downstream dependencies. And we've got a package called Blocker Healthy, which allows you to do this really easily. And we're going to open source this one pretty soon. The fifth principle is build, release, run. So strictly separate build and run stages. And you can do this in Docker using Docker build stages. This is one way of doing it. So first thing is to always build your application in the container itself using this run directive and building your application. And then that avoids having your build be affected by any difference in environment. And then you can copy those built artifacts from the build stage here into the runtime stage. And a common technique is to use a scratch base image here, which is an image that just has nothing in it. It's just super lightweight, really fast to pull up and to spin down, to pull down or to spin up. And it's just executing your binary. The sixth principle is about processes. This is probably my favorite of the 12 factors, and it's one that's had the largest impact on the way that we develop cloud applications at Blocker. The key idea is that your app is composed of multiple stateless processes. We touched on one way to do this at the start, which is to have a separate binary for each process. But the Docker file on the left here uses a build arg to control which application binary to build. And the one on the right allows us to instantiate a single binary with a different application command line argument. And that can be done very easily with the Viper and Cobra tools I talked about earlier. And then together, all of these different processes make up your application. So if you look at your cluster and you're running your app, whatever it's doing, it might be lots and lots of small individual running services that are all communicating together over gRPC. They've all got their own health checks. You can see they're healthy here. And they've all got their own dependencies declared. And they might communicate over message brokers like RabbitMQ, for example. Seventh principle is port binding. So it's a very, very simple principle. It just says, don't rely on the injection of a web server into your execution environment. Instead, simply bind to a port, listen to requests on that port, and you can configure that port with an environment variable. It's a very simple one, but in Kubernetes, you can achieve this by port mapping and traffic routing, which can be handled by service accounts in Kubernetes. The eighth idea is concurrency. So how do you scale out the app? So it's a particular pleasure in Go to do this with its concurrency model. So you've got Go routines, channels. It makes it really easy to scale out your process across the CPU. But remember, at some point, doing more things concurrently isn't going to get you any faster. It's just going to be time spliced on the CPU. So you want to make it easily to scale out across instances as well. And so one way of doing that is to have your application configured as these independent stateless processes that we've been talking about. And you can scale those up using, in Kubernetes, replicas and with horizontal pod autoscalers. The ninth principle here is disposability. So maximize robustness with fast startup and graceful shutdown. And this principle ties to the idea of having these stateless processes. And it means accepting the idea that your application will die at some point, and you need to handle that scenario. And so here's a little snippet that shows you one way of doing this. We've got a capture signals method. It accepts a cleanup function as an argument. And we can use the OS signal package to listen for incoming POSIX signals. And when we receive one, we can do any teardown necessary in the cleanup function in order to safely exit our application. And another important concept for achieving this in Go is using context. And it's one of those really useful and versatile packages in the standard library. Many of you, if you're a Go developer, you know it well. Its usage is widespread through the Go ecosystem. And if you're not familiar with it, context allows you to carry information across API and other context boundaries. So in particular, this is used for deadlines, for timeouts, graceful shutdowns. And it allows callers of your functions to control cancellation of the execution of your function. And so pretty much any function you define, the first argument should almost always be a context. And you also always need to make sure you listen in your loops for those context cancellations and make sure you handle that. And this is a pattern for doing that. 10th principle is devpro parity. Just means keep each of your environments as similar as possible. If you don't do this, then when you release to production, you're just guessing that it's going to work, because production will be different and you haven't tested it in that environment yet, essentially. And there's sort of 3 types of gap people talk about between development and production. That can mean that your code will break. The time gap is the time it takes the developer to work on the code. It takes days, weeks, months before it goes into production. And a 12-factor app should have much shorter iteration cycles. And there's a personnel gap, which is the developers write the code, and then different people, ops engineers maybe deploy it. And in a 12-factor app, the developers will deploy their own code. Kubernetes makes this very easy. And then there's a tools gap, which is, developers might be locally using SQLite on, OS X on their Mac, but in production, you're using MySQL and Linux. And you think this is okay because you've got an adapter in the middle, but it's always the subtle differences that get you. The 11 of 12 principle is logs. Just treat them like event streams. So, a 12-factor app should never concern itself with routing or storage of its output stream. So don't manage rotating log files or writing to some other system via an API. Instead, just dump to stand it out. And you can use a log level config value to control the verbosity of your output. So we'll use debug and staging and info in production, for example. And then later on, you can do queries on your logs by looking at if it's logged in a formatted way with these key value pairs. You can do queries on your logs to understand what's going on with your application. And you can just capture this log stream from your execution environment using something like Fluentd, which you can easily install in your Kubernetes cluster. And then you can stream those logs to analysis tools like CloudWatch. And the final principle is admin processes. So it's about running admin or management tasks as one-off processes. So don't run one-off jobs from your local machine over an SSH tunnel. That's a recipe for havoc and too easy for things to go wrong. So instead, build and execute your one-off jobs just like you do for your long-lived processes. And execute them in Kubernetes. You can use job objects or cron job objects to do that. So that is it. That's a very whistle-stop tour of some of the best practices that we use for building cloud apps with Go in Kubernetes. It might be quite specific to Go at times and Kubernetes at times, but the principles really help write professional production-ready applications and let them scale them. And we've seen a lot of benefit from following these principles. So thanks very much. Appreciate your time.